Hello viewers, I am Kausalya. Today we are going to solve some problems in exercise 15.1 probability. Here we start with problem number 23. A game consists of tossing a 1 rupee coin 3 times and noting its outcome each time. Hanif wins if all the tosses give the same result, that is 3 heads or 3 tails, and loses otherwise. Calculate the probability that Hanif will lose the game. So here we are having a 1 rupee coin which is tossed 3 times. What does this mean? This is indirectly saying that we are having 3 1 rupee coins and we are tossing all the 3 coins simultaneously. Can you get? Okay, that is similar to tossing a single 1 rupee coin 3 times. Am I making clear? Tossing 3 1 rupee coins at a single time is equal to tossing a 1 rupee coin 3 times. Right. So here Hanif wins. When Hanif will win? If the output is 3 heads or 3 tails. But here we are asked to calculate the probability that Hanif will lose the game. So when Hanif will lose the game? When he won't get 3 heads together or 3 tails together. So this is the meaning. So in order to write the possible outcomes, always keep in mind, rather than thinking 1 rupee coin is tossed 3 times, it will be very easy for you if you think in the other way. That is, here we have 3 1 rupee coins and 3 1 rupee coins are tossed simultaneously. Right. So when 3 coins are tossed simultaneously, then what will be the output? We will be having either all 3 heads or all 3 tails, or head tail head, tail head tail, or head head tail tail, tail head head, and again head head tail and tail tail head. So totally here we have 8 possible outcomes. So this is the reason why I ask you people to think that we are tossing 3 1 rupee coins together. Then it will be easy for you, so that in your mind it will be very clear that we will be having 3 outputs for each tossing. Here again the same thing. 1 rupee coin tossed 3 times means again the same thing. For a first time you may have head, and for the second time tossing you may have head, and for the third time tossing you may have head. You have to think like that, and then you have to write the possible outcomes. If you think we are tossing 3 1 rupee coins simultaneously, then it will be very easy for you to write the possible outcomes. Right? So number of possible outcomes is 8 here. Now the next thing is, let E be the event Hanif lose the game. So here when Hanif will lose the game? When he is not getting 3 heads and 3 tails. So just remove these two options. So what are all the possible outcomes here? Then the rest 6, okay? The remaining 6 gives the possible outcomes. So just write down. So number of possible outcomes here is, not possible outcomes, number of favorable outcomes here is 6 in number. So the probability is number of favorable outcomes divided by total number of outcomes. So here it is 6 by 8, here it is 3 by 4. Or again you can solve this problem in other way. First you can calculate the probability of Hanif winning the game. So again we use this formula, probability of E plus probability of E bar is equal to 1. So when Hanif will win the game? When he has all heads and all tails. So totally here we are 2 in number. So here the probability of Hanif winning the game is 2 by 8. So plus probability of Hanif not winning the game is equal to 1. So probability of Hanif not winning the game is given by 1 minus 2 by 8 here. So which is obviously 8 minus 2 by 8. So which is 6 by 8. So finally we are having the same answer. In any way you can solve this problem. So problem number 24. A die is thrown twice. What is the probability that 5 will not come up either time? And second one is 5 will come up at least once. So here again a die is thrown twice is similar to throwing 2 dice simultaneously. Right. So here how many possible outcomes when 2 dice are thrown? Automatically we will be having 36 outcomes. So what are all they? So these are all the possible outcomes when a die is thrown twice or 2 dice are thrown together. So here the first option is 5 will not come up either time. That is, you should not have 5, right? You should not have 5 in the output. So first one is let E be the event of 5 will not come up either time. That is, while tossing the first time also you should not have 5, and again when you toss the dice second time you should not have 5. So what are all the favorable outcomes here? So here among these 36 outcomes you have to select the outcomes which does not have 5. Right. So when you select the items, you see these are all the favorable outcomes. So how many favorable outcomes do we have? They are 25 in number. So what is the probability? The probability is number of outcomes favorable to E divided by total outcomes. So outcomes favorable to E is 25 and total outcome is 36. So here the probability is 25 by 36. Now we will move with the second option. Let F be the event of 5 will come up at least once. That is, you can have the option as 2, that is that both the outputs are 5 or at least one output should be 5. So here what are all the outcomes favorable to F? You see 1, 5, 2, 5. Again you have to, from the possible outcomes, you have to select the output, right? So here 5 will come up at least once. At least once you should have 5. If both the dice shows 5, it is okay. So here you have to note this. You can write this 5, 5 option also, because here the question is you should have at least one time 5. So if you have both the times 5, it is okay. So number of favorable outcomes are 11. So here the probability is number of favorable outcomes divided by total possible outcomes. So here it is 11 by 36. Or again the same thing, you can do it in other way. So here the probability of not having 5 is, no, probability of having 5 is equal to 1 minus probability of not having 5. You can do either way, right? So even you can first solve this and then you can find the another one. So here the probability of not having 5 is 25 by 36, and once you solve again we end up with the same answer, 11 by 36. Now we will proceed with the final problem of this exercise. Problem number 25. Which of the following arguments are correct and which are not correct? Give reasons for your answer. So the first question is, if 2 coins are tossed simultaneously, there are 3 possible outcomes: 2 head, 2 tails, or 1 of each. Therefore, for each of these outcomes, the probability is 1 by 3. So now tell me, if 2 coins are tossed simultaneously, how many outcomes do we have? We will be having 4 outcomes. Here what they have said, they have told we will be having only 3 possible outcomes. And that too, the probability of the outcome, each outcome is 1 by 3. So here our answer is, the given statement is incorrect, because the total outcomes are, these are all the total outcomes. So next is, the probability of all the outcome is 1 by 3. How is this possible? Here you see probability of getting head, okay, both the coins are showing head, then it is 1 by 4. Because head head is 1 in number and the total outcome is 4. So probability is 1 by 4. Similarly, probability of getting both the tails is again 1. So here it is 1 by 4. And the next thing is probability of 1 each. What does this mean? That is, one coin is showing head and the other one is tail. And similarly vice versa. The first one is showing tail and the other one is showing head. So here how many do we have? We have 2. So the probability is 2 by 4. Right. Now we will move to the second part. If a die is thrown twice, there are 2 possible outcomes: an odd number or an even number. Therefore, the probability of getting an odd number is 1 by 2. So if a die is thrown, how many possible outcomes? We will be having 6 possible outcomes, starting from numbers 1 to 6. So here, probability of getting an odd number. So how many odd numbers do we have? We have 1, 3 and 5. So totally we have 3 odd numbers. So probability of odd number is 3 by 6. That is, number of favorable outcome is 3 and the total outcome is 6. So here it is 1 by 2. Similarly, probability of getting an even number is also, it remains the same, because here we have 3 even numbers and 3 by 6, and again the probability ratio is 1 by 2. So that's all. This exercise 15.1 gets over with this problem. If you have any doubt, let me know in the comment section. Thank you.